Alrighty, guys, I'm gonna do a quick little review video because we won't have time to go over this in workshop. Alkyne nomenclature is honestly very simple. It's nothing major, but I just wanted y'all to have a video to reference. The key things is gonna be the parent name. Now if it only has like one triple bond, you'll just have like you'll just write as normal. But now you'll be adding the ending Y and E. Now you can have double bonds and triple bonds within the parent chain, so you'll see how to write that. And then if it's a substituent, then it's YN, YL, and that's that for now. The other thing, if numbering is equal for triple bond and double bond, then you want the double bond to be priority. Otherwise, triple bond is now more major. So we'll do a basic one. So here we just want to see how fast we can hit the triple bond. So here we have 1, 2, 3, 4, 5, 6, 7. So again, we know that our parent would be hept. And then now we have 3 Y and E. And then you can write 3 heptyne. Right, and it's only one, so you don't have to write hepta. So that would be the parent. Okay. And then remember, we have our substituents. We have 3 methyls. We have 1 at 2, and then we have 2 at 6. So 2,6,6 trimethyl. And then there is no stereo with triple bonds. So, and there's nothing else. There's no double bonds or RNS here. So we would have no stereo in this one. So we just have 2,6,6 trimethyl hept 3-ine, or you can write the other parent chain ending. And that would be it for a basic alkyne structure. Let's go over another example. So now we have the incorporation of like cyclic structures as well with triple bonds. So we'll go over that real quick. 1 second. Okay. So in this situation, the question would be, would the triple bond be priority or would the cyclic structure? Now, we would prefer the cyclic structure to have priority because of the fact that we have a longer chain within the cyclic structure. So, 1 second. Sorry guys, I'm trying to pull up a file for some of the notes that I have and it's making me silent. Alrighty. So we would have 1, and then remember, once you start a double bond, you have to finish it. So we go 1, 2, 3, 4, 5, 6. So we have a longer chain rather than just the triple bond on one of them, and we have 2 double bonds. So it would have more priority. So now we know that our parent is going to be cyclohexa 1,4-diene, or you can put 1,4-cyclohexadiene, whichever fits your boat. Then our substituents, right? So we know we have a substituent at 1-, and we know we have to start numbering from, so 1, 2, 3. So we have 1 bromo, and then you can either write 1 broma, 2 This is a 3-carbon chain, so propanil. Remember, YNYL. Or you can write it as 1-bromo prop, prop-2-YNYL. I think I prefer the first way. I feel like it's way easier, but whatever is fine. And then again, there is no stereochemistry with double bonds within a cyclic structure, and then triple bonds themselves do not have any stereochemistry, so we do not have any here. So the final written out answer would be 1-bromo. And then you can for there we go. And that would be how you would do that. So let me find one where we have a double bond and triple. So here we have a double bond and a triple bond. So if I count starting on the side where I hit the double bond first, 7, 8, 9, 10. Our double bond is hit at carbon 3. And then if I number starting from this side, 4, 5, 6, 7, 8, 9, 10. Our triple bond is also hit at carbon 3. So remember up here, I said, if you have the situation where the numbering is equal, so meaning you number from different sides and you hit the triple bond and the double bond at the same carbon, so in terms of numbering, carbon 3, then you will consider the double bond to be priority. So in this situation, we will say that our final counting will be the pathway, which is in blue. So this is just one of those where situations that you have to make sure you remember, because sometimes they'll test that on the exam. So our parent would then be, we have a 10 carbon chain, so dec. We have 3 ene, and then you always want to do stuff alphabetically. So Y is after En, so you're going to put your double bonds naming first, and then you'll finish with 7 YNE. So in this situation, you do have to write it within, because what do you call it? Or you can write it as dec en 7 ein, but this method I highly suggest you do, because I feel like the other method is too confusing. And then remember your stereo. We do have a double bond within that has 4 unique things attached to it. So I'm going to say that this group is high compared to just a hydrogen. And then the methyl compared to this long carbon chain, this is high, this is low. So in this situation, we do have at 3, we have E. And remember, you can just write E, because you can assume that since there's only one double bond, that is where the stereochemistry is in this situation. And then I did forget subs. We do have 2 methyls. We have one at 4, and then we have one at 9, so 4,9 dimethyl. And then to put it all together, you would have E-4,9 dimethyl, and then dec 3 ene. And remember, you don't put E because it's not at the end. You don't 7 YNE. And that would be that. And then the last question is another one. 1, 2, 3, 4, 5, 6. So you hit the triple bond at 1 and the double bond at 4. Whereas if you number like this, 1, 2, 3, 4, 5, 6, you hit the triple bond at 5 and the double bond at 2. So you hit something the fastest going from on the red pathway. And this is not a situation where the double bond and the triple bond hit the same carbons at once. So this is just general rules where now triple bonds have higher priority. So again, our parent, we have a 6 carbon chain. So we have hex 4-ene-1-ine. Our substituents, we have 4-cyclopropyl. And then for stereo, we do have an internal double bond that does have 4 unique things attached to it. This would be the low and the high, and this would be, so this is where it can get tricky. This is considered the low and this is the high. Why? Because here you directly encountered carbons and then carbons and then carbons. Whereas here you hit CH2 first, if that makes sense. So this one would be considered, let's see, what is that carbon? 4Z. So here you can just write Z. Change the color back. And then you have 4-cyclopropyl hex 4-ene-1-ine. And that would be your final answer. And then you would be done. Now I wanted to show y'all, I just want to make sure I think I got this from 2013. Let me make sure. And this worksheet we'll go ahead and post on Canvas for you all so you can work on it during break. And then we'll also I'll upload the actual file on Monday, and then the answer key I'll upload on Wednesday. But I'll upload this video so that at least you have this to get started, and then I just want you to have time to actually work on it on your own before you start using the answer key. Now, the last thing I want to do is give you examples. So I want to say this is from 2013. I just pulled up a random exam. This is exam 2 of Bean Weebly website. And this is a great example of how you would be tested for your knowledge of like alkyne nomenclature. So here we don't have any double bonds or anything, so we're just trying to get as close as we can to the alkyne when numbering. So I would start here. Oops, oh my god. Having some technical difficulties. There we go. So 1, 2, 3, 4, 5, 6, 7, 8. If you kept going to the left, you would hit 7 carbons instead of the longest, which can be 8. So our parent here would be oct-2-ine or 2-octene, however you want to say it. And then our substituents, we have a substituent at 5, and it's just a 2 carbon chain, so 1, 2, which would be ethyl. So we just have 5-ethyl. Remember, there is no stereo with triple bonds, so none. So 5-ethyl oct-2-ine, and that would be your final answer. And I'm going to cross-check myself right now, because again, I like to do things without the answer key so that you can see that I'm going through it with you all. Maybe it was 2014. Oh brother. Hold on. Give me 1 second, guys. Oh, sorry, guys. This was actually from exam 3, 2013. I definitely forgot that you don't really learn this until... Usually you don't learn this until the last midterm. So that's also why I had it wrong. So this is from 2013. And just to verify, okay, so for some reason on the answer key, it looks like there was a typo whenever they made this problem, like whenever it was uploaded, because if you look on the key, the original provided example is actually this. But we'll just show you how it would be with this. So if you have this 1, 2, 3, 4, 5, 6, 7, we hit the double bond at 2, and we hit the triple bond at 5. If I number the other way, so 1, so 1, 2, 3, 4, 5, 6, 7. We hit the double bond at 5, triple bond at 2. So now remember that you're hitting them at the same numbers. So double bond will overpower triple bond. So we would go in the order of the red way, and then you would name as such. So when you look at the answer key, you're going to see this version, but I guess when I took a screenshot of it, this is how it looked. So you just got 2 examples in one. You won't have to know alcohols for this exam, so I don't know. I don't think I'm going to go over this, but I'm not going to go. Oops. If you were given this problem on an exam, the question is, which one would you choose, right? Now, yeah, actually, no, I'm not going to go over this example because this is particular into what it's going over. But yeah, here's an exam question version of how you would go about this question, and then here are practice problems. So I hope this helped. That's literally all the alkyne nomenclature you need to know. And then if you have any questions, please let Chet or I know, and make sure to continue working on your reactions.